Welcome back. In this session, we'll continue with the discussion on this how to obtain this output of the system without resorting to the convolution sum formula, means just using the time invariance and linearity property directly without resorting to these two formulas. How do you compute the output using time invariance and this linearity property? Now, what we'll say in this session, we'll say the input to the system is combined input, means we'll say the input is twice delta n plus, we'll say twice delta n plus twice delta n minus 1 and delta twice delta n plus 1. Now, what is this saying? We'll apply this as the this plus this as the input to the system. We'll say the input is now this one, this one, this one. Now, if these are the input to the system, it's together, these are the input to the system, what should happen to the output? Now, if the system follows the linearity property, the output should be simply the sum of these individual responses. So the output for this will be sum of this, and sum of this. That's what should happen to the output. Okay, let me redraw this. This means simply now, let me show you the illustration here. So let's illustrate it. So this is our system, and the impulse response of the system is, this is the impulse response of the system. Now what we are saying, we are going to apply a weighted sum of inputs as input to the system. We'll say the input to the system will be twice delta n plus, let me suppose 1 by 2 delta n minus 1 plus twice delta n plus 1. So this is the input to the system. Now what will be the corresponding output? See, if I apply these inputs individually first, so what's the output for this? We already saw the output for this is, let me write it here. I hope this is visible. So the corresponding output for twice delta n is simply, corresponding output is twice h. So the output for 1 by 2 delta n should be 1 by 2 delta, sorry, not delta n, h of n minus 1. And the corresponding output for this should be twice h of n plus 1. So this should be the output. Now what we are doing, we are applying this as input to the system, means we are applying this as input simultaneously to this system whose impulse response is this. So the output should be the sum of the individual response. That's the property of the linearity. This is what is actually linearity property. Means if you apply a weighted sum of inputs to the system, the output will be simply the sum of the individual response for each input. Means sum of these inputs. So the output is simply the sum of these individual responses. This is the beauty of this linearity. This is what a linear system actually means. So let me write the inputs first in sequence form. So the input is 0. This means, let me write the values first 1 by 1. So this will be multiplying every sample point by 2. So if I write it like this, this means this will be, this is for simple illustration. You know what will be the input directly. And this is for you guys to illustrate you. This proceed step by step. Now the input is 0. 1, 0. This means delaying the input by 1 sample, and this 1 by 2 means scaling the every sample point by 1 by 2. So if you scale up the sample point by 1 by 2, this means this is the input. Now what we are doing, so now the input is, this means shifting the sequence towards left, and we are scaling it by 2. This means 0. 1, no, sorry, this will be 2. Scale every sample point. This is the input. Now the output for this input is twice h of n. What's h of n? 1 comma 1. This means scaling the every sample point by 2. So if you scale the every sample point by 2, the corresponding output will be this. Similarly, this means del h of n minus 1. H of n minus 1 means delaying this by one sample point. So this is the delayed version of h of n. This means scaling factor is 1 by 2, not 1. So scaling factor is 1 by 2, and to multiply every sample point by 1 by 2, we have 1 by 2, and this is equal to 0 point. Same way, this means shifting the sequence towards left. This is the meaning of shifting the sequence towards left, and we are scaling it back to. So multiply every sample point by 2. So this is the output. Now what we have to do, if we apply this as the input, means weighted sum of inputs, the output should be the sum of these individual response, corresponding individual response. That's the meaning. So this is the meaning. Now what we are doing, if I say this is the input, combined input, so the combined input to the system is if you add these inputs, so the input is this. If you add the corresponding sum, this is n equal to 0 point, n equal to 0 point, and n equal to 0 point. So the first at n equal to 0, the value is 0, then n equal to 1 point. This is n equal to 1 point, n equal to 1 point, and n equal to 1 point here is 0. You can assume that 0, so it is 1 by 2. Then n equal to 2, you know that will be 0. You can check it. Now n equal to minus 1 point. This is n equal to minus 1. This is n equal to minus 1, and this is n equal to minus 1 is here. Sorry, not this. N equal to minus 1 is in this value. So this is 2. So equal to minus 1. So this is the input to the system, or in other words, you can write it like this. So we say the input to the system is twice delta n plus 1 plus twice delta n plus 1 by 2 delta n plus 1. So this is the input to the system. Now this is the input to the system whose impulse response is, sorry, let me read all this. Whose impulse response is h of n. Whose impulse response is h of n. So the corresponding output is simply the sum of these. So the corresponding output will be twice h of n plus 1 plus twice del h of n. So the output for twice h of delta n is twice h of n plus 2 of n. Now if you sum these, this means simply the summation of these. And if you sum it, to sum the corresponding value, first let's get n equal to 0 point. So n equal to 0 point means now this is n equal to 0 point, this is n equal to 0 point, this is n equal to 0 point. So this will be 2 plus 0 plus 2, that's 4. So 4. So this is n equal to 0 point, then n equal to 1. This is 2, 1 by 2, and 0. So 2 plus 1 by 2 will be 2.5, that's 5 by 2. Then n equal to 2 point. N equal to 2, you can check, is 0 here, it's 1 by 2 here. So, and it is 0 again here, so this will be 1 by 2. And rest of the samples are 0. Same way, n equal to minus 1 is 0 here, it is 0 here, and it is 2 here. So you can see. So this is the output when the input to the system is this. So when the input to the system is this, this is the output. Now without resorting to this formula directly, we illustrated how to compute output of the system using this time invariance and linearity property or linearity property of the system. All right, let me end it here. In the next session, we'll say how do we generalize this? How do we can generalize this concept? All right, let me end it here.